Good morning, this is Arun. Today we are going to see doubly linked list. In the last class we have seen the singly linked list and introduction to the singly linked list. So now we will see the doubly linked list. Okay, now we will see what is a doubly linked list. Doubly linked list is a complex type of linked list in which a node contains a pointer to the previous as well as the next node in sequence. So for singly linked list we have data and the address of the next node. So it has only two parts in the singly linked list. One is data and another one is the next, that is address of the next node. But in the doubly linked list for a node we have three things. One is previous, one is data, and another one is the next. That means it will point the next address, next node of the address, and this will point the previous node address. That is what the advantage in the doubly linked list. So this is the head pointer, that is the starting pointer. Okay, see here, therefore in a doubly linked list a node consists of three parts. Node data, pointer to the next node in sequence. Sequence means next pointer, pointer to the previous node, previous pointer. So this is, you call it as previous pointer, this is your next pointer, and this is the data. In the singly linked list we have only two part, one is data and the next pointer, but here we have another part, that is the previous pointer. So that is the main difference between the singly linked list and the doubly linked list. Okay, a doubly linked list contains three nodes having a numbers from 1 to 3 in the data part is shown in the following image. You will see that. So I have already said that. So it has three parts. See here, this is the starting, this is the head pointer, so it points the first node, that is so see, it also contains three node. Here why I have given into mark means here there is no previous node, so here there is no previous node, that is why I am giving a into mark here. So this is the data, this contains the address of this node. For example, here address is 200, it will point the address 200. So for example, this node has address 100, it will point the address here as 100. So here 300 means it will point the address 300 here, and it will point the 200 here. This is the null, so it is null, or you can mark it as 0, anything. I have marked it as a into mark. So in the node part contain here three things. One is previous address, one is data, and another one is the next address. So here see how we can give the structure for this. Struct node previous. So this is for previous. So in the singly linked list we don't have this previous part, only we have the next part. So struct node previous, pointer previous into data next. So this previous defines this part, this next defines this part, and this data defines this part. Okay, this is what the explanation for this struct node structure. Now we will see the detailed explanation for this. The previous part of the first node and the next part of the last node will always contain null, indicating the end in the each direction. So null means see here 0. See here, this is null and this is null, because there is no node before this node, there is no previous node before this node, that is why null. And after this node there is no other node, so that is why here I am giving it as null. So that is what they are saying here. See here, the previous part of the first node and the next part of the last node is always containing null, indicating in the each direction. So why I have given into mark means so it is a last thing, that is why I have given the into mark. For example, in the train at the last compartment you may see in the into mark that indicates that this is the last compartment. Likewise, if I give the into mark in the doubly linked list, that is, it is the end of the node, that is the last node. Okay, now we will see the memory representation of a doubly linked list. Memory representation of a doubly linked list is shown in the following image. Okay, before that, we'll see. In a singly linked list, we could traverse only in one direction. So this is an important thing, because each node contains the address of the next node. So see here, in a singly linked list, only two part, one is data part, another one is the which contains the address of the next part. So this part is omitted in the singly linked list, so it will contain the address. So here bidirectional, so this is the important thing here. Bidirectional means both the ways. That is the thing they are saying here. So see here, in a singly linked list, we could traverse only in one direction because each node contains the address of the next node and it doesn't have any record of its previous node. However, in the doubly linked list overcomes this limitation of a singly linked list. So it overcomes the disadvantage in the singly linked list, that is, it has only one direction, but here we have two direction, that is bidirectional. Due to this fact that each node of the list contains the address of its previous node, we find all the details about the previous node as well as the previous address stored inside the previous part of the each node. So we can, with this bidirection, we can have the address of the previous node as well as the address of the previous node as well as the address of data contained in it. Next we will see the memory representation of a doubly linked list. See here, memory representation of the doubly linked list is shown in the following image. Okay, we will see that. Generally, doubly linked list consumes more space for every node and therefore causes more expensive basic operations such as insertion. Why it consumes more space means, in the single linked list we have only two part, one is data and the next part. So for example, I am declaring this data as an integer, so it will occupy only 4-bit integer, 4-bit, and if this part, and it also occupies 4-bit, totally 8-bit. But here three things: previous, it appoints the previous node address also, so it is memory is exceeded when you compare to singly linked list. So more however, we can easily manipulate the elements of the list since the list maintain pointers in both the direction, that is forward and backward. In the following image, the first element of the list, that is 13, stored at address 1, the head pointer to starting address 1. Since the first element being added to the list, therefore previous list contains null. The next node of the list resides at the address 4, therefore the first node contains 4 in its next pointer. We can traverse the list until we find any node containing null or -1 in the next part. Okay, we will see that image and I will explain that. So see here, this is the head, so it points the first, it has a data 13, the previous is -1, so the next is 4. So this is the data, this part is a data part, the node, the first node has data 13, previous means before that, so this is -1, next means 4. It contains address of the next node. So where is that 4? Next, here. So it is it is at the address, it is at the memory 6. So it contains the address of the next means 4. So okay, so it should in the memory linked list will be not in a sequence order, so it will be in the random order memory. That is also one of the important point. So see here, 4 means it has the next is 4. We'll see there. Okay, so 13 is the data. Here 15 is the data. Previous is 1 and the next is 6. Where is 6? See here, it is not randomly stored. Here it is not 6. So here -1, here -1. That is null. Here it ends. So this is the first data. This is the second. This is the third. This is the fourth. So see here, but the address, see where it points the address. 4 is where? Here. 6 is where? Here it points. So this is how it points. It is not randomly stored. It is not sequentially stored. It is not sequentially stored. It is randomly stored in the memory. That is the important thing you should know. This is the memory representation of doubly linked list. See how we are getting a node here. Already I have said how to create a node. So see here, structure name is node, struct node previous, because it has 3 parts. The node contains 3 parts: previous, next, and the data. See here. So struct node dot head. This is how we are creating a node creation. We will see a program after completing the doubly linked list in the next class. We will see the operations on doubly linked list now. See here, there are 8 operations in the doubly linked list. First operation is inserting at the beginning, adding the node into the linked list at beginning. If you are adding a node, that means it has to be contain 3 parts. One is data, one is previous, and another one is the next. So insertion at the beginning, adding the node into the linked list at the beginning. Next, insertion at the end. Here also it is possible, adding the node into the linked list to the end. Insertion after the specified node. For example, if there is node, if doubly linked list contain 10 nodes, you can insert at the 7th node or 3rd node or at the 9th node. So that is very easy here, adding the node into the linked list after the specific node. Deleting at the beginning, you can remove the node at the beginning, that is removing the node from the beginning of the list. Next one is deleting at the end, removing the node from the end of the list. You can remove from the beginning first node, also you can remove the last node. That is also possible here. Next, deletion of node having given data, removing the node which is present just after the node containing the given data. You can delete the node wherever you want. That is, if you having 10 nodes, if I want to delete the node at the position 9 or at the address, for example, to 400, likewise, that is possible here. Searching, comparing each node data with the item to be searched and return the location of the item in the list of the item found, else return null. If you are searching for some node that is at the address 500, that is, if the node is present, it will search and it will give you the answer. If not, you will found return null. Traversing, visiting each node of the list at least once in order to perform some specific operation like searching, sorting, display, etc. These are the traversing advantages of traversing. We can search, we can sort, and we can display the nodes. Display. Okay, this is the thing about the doubly linked list. The last class we have seen single linked list. This is the doubly linked list. Next class we will see the circular single list and circular doubly linked list. Thank you.